So in this demo, we'll be focusing on production monitoring and how operators can interact with the system, and also what data is automatically captured from the machines without any operator interaction at all. So just as a quick overview, this is the MachineMetrics interface. We see your list of machines, and we have 4 machines here connected. You can see a stamping press, a lathe, a grinder, and a milling machine. Now what you'll notice is that 3 of the 4 machines already have an operation running, and that's because that data is automatically being pulled from the machine data. But this one machine, lathe, it's an older machine. It's using a basic I/O sensor, so we're not getting program data. So in that case, we're not able to get operational data from the machine itself. Just quickly in this list here, it's very configurable, so you can select what items that you want to see and save those views. This is just a basic utilization view. We can also switch that to, say, parts goals. We can see how many parts have been produced, and also change the range of time. So let's look at this last 7 days. So just a quick overview of the application itself. So we have essentially our machines here. So anything dealing with machines, the list, our dashboard that you might see on a big screen TV, and some other information you can see here on machines. We have reports, out-of-the-box reports, but also a report builder that allows you to build your own. We have all of our production information in this area, and then our workflow and automations here, which is really sort of the main areas of MachineMetrics. So what I want to point out is that we'll focus on this milling machine and the lathe machine. So I want to show what data is being pulled from this milling machine. We connected this to a FANUC-based control, and we see that we're going to be able to pull many data items from that control. These are the default data items, but we can also extract really any diagnostic parameter, any PMC parameter. Some of this might be useful for maintenance, for condition monitoring, but I want to draw your attention to this path1 program name. So that program name, which is sample here, really indicates the current operation on the machine. Now, in some cases, that program name is just a number, a 0, a 1. It might not be related so closely to the operation that you're making. So we also have the program header, which you can also pull from the program header if this data is more relevant. And what will happen is if there's a new program that appears, that operation is automatically created in MachineMetrics, and the machine is now associated to that new operation. So if I go back to the machines list, you can see that there's a lot of data here. We can automatically create that operation from the machine data. There's no operator input required. As soon as you connect that machine, we're getting historical information around what's running on that machine. So let me draw your attention to this other machine, the lathe. Let's go into that, and you'll see there's only a couple data items here. Essentially, we're getting on-off execution, and we're getting part count. So these are 2 different sensors on that machine, and there is no program information. This is often the case if you have like a 50-year-old machine, or maybe it doesn't have a modern PLC. It's on an Ethernet connection, and we're unable to get that data from the machine. So in this case, we're going to need some operator input in order to understand what's running on that machine. So let's now look at what the operators experience. So if we go to that 3-axis mill, we'll see a few things here. So this is a configurable operator interface. There's a lot of data you can or you can decide to not show to the operator, but it gives you this performance ring that shows you how many parts have been produced compared to the goal. So if you have a standard that's been set, this will actually track your performance to that standard. Now, there's nothing that the operator has to do here. We're automatically capturing this data. but it's useful to have this in front of the operator so that the operator knows if they're meeting their goal. Now, there's a couple things you might note. Work order information is often required in order to synchronize your production information to the ERP. That information often does not exist in the machine data, so that will require some input. So we're going to, one of the things that you might want the operator to do if a new operation is starting on the machine, and it doesn't have to happen right at the beginning. It could be when there's some extra time, some downtime. The operator can essentially click this work order, add a work order to that machine. Let's call that work order 1021. And now we're actually tracking that work order and the operation so that when it comes time to send this data to the ERP, all the information here is laid out, and that synchronization is made very, very easily. So there's nothing more that the operator needs to do. If you elect to this, you could have the operator categorize downtime. In this case, we can categorize some previous downtime. Looks like there hasn't been any of this shift. But what we can do is I can go in here and stop the machine, and we can actually we can see what actually shows up. So this essentially will prompt the operator to enter in downtime. There's a couple second delay between the machine and what you'll see in a system here. So here you can click categorize. This might be, let's call this a maintenance issue. It's unplanned. We can submit that, and now you have this information for reporting. But let me stress that this categorizing downtime is not required. It's something you might want either for a period of time to understand your bottlenecks, or you might not ever want your operators to categorize downtime. It's optional. So now let's move to the machine that does not have operator information. This is that lathe. It's just using a couple sensors. And in this case, the operator will have to do a little bit more work in order to understand what's running on that machine. So in this case, you see this button here, Start Run. So we can go ahead and start that run since we're running a new program. And we're going to call this is something new. Let's call it a wheel nut. All right. Now we'll notice that there's no wheel nut that already exists, so we can go ahead and create that wheel nut. We'll give it a work order number, work order 1022, and let's create that and start the run. We're going to start that right into production, and there we go. Now that happens to be down right now. Just going to dismiss that. So we now know that we're running work order 1022 and it's wheel nut. And if I go into MachineMetrics, I'll see that there's a wheel nut that's running on that as the current operation. Let me go and show the operations here. So we could see here's the wheel nut, and there's no operational data item that's tied to. So this really gives you the that's all that's really required on behalf of the operator. This data is completely structured in a format that can be sent to the ERP. It can be done through APIs. It can be done through an interface, and you can go and let me show you a little bit of the reporting. So if we go into say this sample program or this mill, let's go and drill into this. So here, this sample operation. Let's go view an operational report. And this will pull in, all the machines that this operation ran on, so the mill, and it ran on that lathe at one point. You could see where that downtime came from if you have your operators classifying downtime, and also any rejections. These features are both optional, but let's drill in a little bit further into this mill, and we can see each of the production runs here. We can see how many parts were produced, how much time that machine was down, the expected cycle time, which is 3 minutes and 40 seconds, and the actual cycle time, which is 3 minutes and 46 seconds. So this, and then one more thing that we can show, let's drill into when this machine was run. Let's go straight to the timeline. And this timeline really gives you full detail, full history of when that machine was running, when it was idle, the reasons for that machine being down, should it be classified, the actual programs and any particular alarms. So pretty cool, right? So finally, the thing that I wanted to point out, which is really useful for a lot of our customers, is the idea that this also acts as a communication tool. So you might, so instead of having the operator having to spend time to click and click and click, there might be a time where there's an issue and you need to call for engineering. So if we go to workflows, we can set up a workflow. Actually, let's do that right now. Let's go and we're going to set up a workflow that will allow the operator to call an engineer. So we're going to call that call an engineer, and that trigger is going to be a manual button. So call an engineer is the description, and the action will be a notification, and I'm going to notify myself, and let's go create that workflow. So now, if I go to, let that reload. So if I go to workflows, we can call an engineer, say there's a problem, call engineer, and now I'm notified right in my phone that there was that engineer was required. So I can come over and we can resolve that problem, and we don't have to go track them down. It all works with whatever systems that I have and can cut down some of that time. Another example of a workflow that I'd like to demonstrate is one that's already been set up. You can see here there's a feed override below 100. So this is based on a condition, and we're going to set a notification and also display a message to the operator interface. So this is in, I forgot we stopped that, so let's go and start this again. Let's see. Your weapon, let's take that, there we go. Start the cycle. To go reset that. All right, and at the beginning, reset, auto start. Okay, so now let's change that feed override. And what I'm going to do is, as an operator, I've turned that feed override down, and we can set a time frame of say 10 minutes, right? Operator is getting a message that feed override is less than 100. Please reset. So I also, as a supervisor, received a message saying the override is below 100. So this is incredibly flexible and could be really created for any machine condition, any scenario, and can really help ensure that these machines are kept running as much as possible, and ultimately increasing your machine uptime. So there's a lot more to MachineMetrics. This is just a basic overview. You can, this production data is really could take a lot to put it together. There's a lot of manual input that we've really filtered that down to what's absolutely necessary. Tying in work order information if you need that, if you want to send this data to your ERP, you don't have to. And operational data that comes directly from your machine, and only if necessary for older equipment, then operational data is pulled from the operator. So with that, I'll let you go. I will open up to any questions.